And here's my solution. First, I compute the mean using the mean function, assign it to a new variable that I make up called mu. So this is now inside the variance. I now know the mean. And here's how I construct my new list, my n data list. I first set it to the empty list. And then I go through every index in the original data structure. So len data, as we know, gives me the number of elements. Range constructs a list of indices from 0 to 1 minus that. Then I go through them sequentially, and that allows me to index the ith item in my data structure. Now, I take the ith item, I subtract the mean, and this is a very short notation for squaring it. I could have just done the same times itself. But this is my new ith element that I append into my n data set. So by doing this with a for loop, I get a parallel data set called n data. That is data minus the mean squared. Now I compute the mean of that new n data and return it. That's my variance. It turns out there's an even more elegant version to do this in Python. And it requires a good amount of programming skills that are probably way beyond most beginners' programming skills. But here's how it goes. You can do this in 2 lines. You can compute the mean, as we've done before with our function mean that we programmed ourselves. And here's the tricky part. We're now going to compute the mean of a new list, and we can construct this new list in a single line. That's the key thing here. The way we construct this is we go through all data items for x in the data, and we construct a new list out of it, where the math from constructing the new list is x minus mu to the square. So this loops through all the data items and applies this equation to each data item, constructs a new list, passes this list on to the mean function, and returns the correct value. So this is one of the most compact ways of programming the variance.